activity in the program was really to validate what the TFP capabilities were, on its own accord, what type of radius, what type of thickness can the TFP handle, as well as then once we did have an optimized result, can the TFP manufacture that? So in order to develop a method to manufacture, we conceived a couple different ideas. There was really 3 different things that we trialed, 2 of which were, I'd say, highly successful, 1 of which was difficult at best. But using this radial bands preform, we prototyped all 3 methods of manufacture. The first method of manufacture uses these discrete silicone call inserts. As Ryan explained in the design portion of this, these panels are 2 layers of Kiso heavy material from AMP Technologies, which is 0 ± 60 material off the roll. And then those are stitched, the TFP preforms are stitched directly onto the Kiso material in one case, and that builds up half the thickness. And then the other half of the thickness of the TFP insert is stitched onto essentially a carbon scrim layer that can be then cut out. And then the second layer of TFP is inserted on top of the first layer of TFP. So what you end up with is this peak and valley kind of construction, where the peaks are the top of the TFP, and then the valley is going to be that Kiso material. And in order to fill that or prevent resin from filling into there, we filled that, in this case, with water jet cut pieces of silicone insert. And the height of that silicone insert was nearly matched to the height of the double stack of TFP inserts. Once the silicone inserts were in place, the panel went under vacuum bag. There was some flow media put onto the panel to allow for flow assist. And then we actually Vardum infused the full dry fiber preform and did an oven-only cure. In this design, the Vardum was a good manufacturing approach, and we actually were able to use the exposed fiber in the TFP as some of our resin flow path for the resin during the infusion. So then looking at the results of the infusion, and this is actually the first panel that was done, the silicone insert piece is shown here on the right, and those are the results of that. And then the other method of manufacture, which I apologize I don't have more pictures of, actually used a fully contiguous silicone call sheet that dropped over the TFP preform. So in that manufacturing approach, we had an aluminum, we'll say silicone call tool that was basically the inverse of the preform, and we're able to cast a silicone call sheet on that aluminum tool. And then similar idea, the TFP preform was constructed onto the Kiso. In this case, the method of manufacture was actually representative of resin film infusion. So we took the dry fiber, poured resin onto the dry fiber, put the sandwich construction together, put the call on top of the silicone call on top of that. That went under vacuum bag and then actually went into the autoclave for cure. So we had both a out of autoclave cure option and an in autoclave cure option as well. And so here you can see both panels side by side. And, really, again, both panels had very good initial results, and we've got a little bit of test data here to kind of look at that. So again, silicone insert and silicone call, 2 different panels. Interestingly enough, when we look at the fiber volume for the silicone inserts, which was the oven-only cure process, we see about a 50% fiber volume, a little bit higher void content, about 2.8% void content. If we look at the silicone call sheet, we're at 49% fiber volume, so fairly similar, and a 1.8% void volume. So again, initial screening tests look like these are both viable manufacturing options, and they'll have their different benefits for different types of geometries as well. We also screened out different radiuses for what the TFP machine could manufacture. So some of these have different radiuses and different geometries as well. So then I apologize because we're running out of time here. I don't have images of the actual branches panel, but we did fabricate a branches panel as well and had very similar initial screening results to these radial band panels. So ultimately, at the conclusion of our phase 1 here, we believe that we're well on our way to demonstrating a topology optimization software solution through UDRI. That's going to be able to design these aerostructures away from the conventional sandwich construction and move towards a TFP topology optimized construction. And then on the method of manufacture side, again, we believe that we're well on our way to developing a robust method of manufacture for both in autoclave and out of autoclave solutions that are going to allow us to manufacture these components at a low price point. So we just submitted our phase 2 proposal with the Air Force, and we're hopeful to move into the phase 2 program late this year. So with that, we'll turn it over to any questions.
Thanks, Tom. There was one question that came up and asking about how big the panels could go that Ryan did answer online. So if you go in the Q&A, you'll see that it was answered about how big you can go. So, you know, because it's theoretically roller roll construction, you could go pretty large. Might still need some joining, especially if we do something like a Taylor fibered wing skin or separate TFP pieces for interior ribs or spars. You know, so you know we are at the end of our hour. I think it will be kind of interesting to see where you go when you do a full wing. You know how you do the